Yeah, I can see you fine.
Yeah. Now we still have 1 minute for coffee break.
Okay.
The participants still in the outside of this room.
Okay. Okay. No worry. No worry.
Okay. Thank you for joining us today.
Okay. I'll see
See
you
you.
in a while.
How are you today?
I'm fine.
Fine. Okay. Good.
Okay. Okay. Let's come back again. I'll come back again in 5 minutes.
Have your seat back.
Yeah. Who is that?
Yeah. We still set up the voice to hear me.
Okay.
Yeah.
Okay. Okay. Go. Go.
Please, everyone, have your seat back because we will start on our second topic of this day.
Recording in progress.
We will start it at 10 a.m. sharp. Okay, ladies and gentlemen, welcome back again on our second topic of this day at for the summer course 2023, Managing Forestry Landscapes and Forest Development Communities to Bridge the Future, Learning Across Governance Regimes. Ladies and gentlemen, commence our activities. We're gonna move to the second topic, that is precision forestry for monitoring forest carbon stock, which will be presented by Dr. Mui How Phua from University of Malaysia, Sabah. And before we're gonna really proceed to our second topic of this day, allow me to read a brief introduction of Professor Dr. Mui How Phua. So Professor Dr. Mui How Phua have interest research in forest remote sensing carbon stock estimation and RED plus GIS based participatory planning park planning. Furthermore, this session also will be moderated by Mr. Muhammad Abdul Rahman Subrata, Bachelor of Forestry and Master of Science. And Mr. Muhammad Abdul Rahman Subrata, recently he has one of the publication is the analysis of economic intensification agro-silvopasture at Wiladek, Indonesia. Well, without further ado, our second topic of this day is about precision forestry for monitoring forest carbon stock, which will be presented by Professor Dr. Mui How Phua and moderated by Mr. Abdurrahman. The time is yours.
Okay, thank you for the time and please, may I call Mr. Professor? Oh, the Professor, good morning.
Hi. Selamat petang.
Selamat petang.
Yeah. How are you today?
Okay.
Can you hear me?
Yes, maybe you can make your microphone closer to you.
Okay, I'll try.
Yes, perfect. Okay. Good morning to all ladies and gentlemen. It is truly a great pleasure to be here. I wish you all are doing well. Welcome back to the second session of the day for the forestry summer course, UGM, with the grand theme of managing forestry landscape and forest dependent communities to bridge the future, learning across governance regimes. As you may have been familiar with, I am Abdul. You can call me Mas Abdul or Tul from the Social Forestry and Economic Laboratory, Forest Management Department, University of Gajah Mada. I will be moderating you throughout this session. Ladies and gentlemen, carbon stock, carbon sequestration, and carbon trade are becoming hot issues today. Some frameworks have been developing to meet fairness method on carbon trading. However, direct terrestrial carbon measurement is very costly due to the expensive of labor, number of terrestrial tools, rainy season, and some difficult remote location to access. So many researchers conclude that remote sensing is an effective method predicting the carbon stock above and below ground. Even though I remember wise men say garbage in, garbage out means that everybody be able to use GIS and makes their own prediction on carbon stock, but the accuracy and precision is still be questioned in spite of the fairness of carbon trade itself will be emanated only if the data has responsibility on the accuracy and precision. For the waited moment, it is now my pleasure to introduce our keynote speaker, the expert of remote sensing from University of Malaysia Sabah, Professor Dr. Mui How Phua. Professor Dr. Mui How Phua will give us insightful overview regarding precision forestry for monitoring forest carbon stock. To Professor Dr. Mui How Phua, you will have 60 minutes to present your presentation. After that, we will be having 30 minutes for Q&A session. So, Professor Mui How Phua, the time is yours.
Thank you. Thank you, Mr. Moderator. What's your name again? Sorry, I forgot your name. Abdullah, is it?
Dul, Mas,
Dul, yeah.
Mas
Okay.
Dul,
Okay.
Mas Dul.
All right, Dul. Thanks. First of all, thank you very much for inviting me to to join as a guest speaker or lecturer for this summer school. I checked the content. The content is very nice, has a broad scope covering from social forestry to lab-based fieldworks and all that. You also have a lot of cultural activities. Yes, you're right. Hi, my name is Phua. So I'm from Malaysia, here in Sabah, the northern part of Borneo. We are just neighbors. So I was in Gajah Mada in March. We had a very fruitful symposium. And I'm very happy to be able to share some of the work that I have done over the past 10 years or so. All right, so allow me to share my my presentation. Can you see my presentation? Is it okay?
Yes, okay.
All right, great.
Sorry,
So,
but please make your microphone closer again so we can.
oh, because my screen is a little bit far from me. Okay. Okay. So or perhaps I have to speak very loud. Can everybody hear me? Is it okay now? Is it better?
Yes, better, much better.
All right. I will also try to speak as loud as I could. Am I speaking too fast? No? Can you see my slide?
Yes,
Okay,
Prof.
great. So as you can see, the title may be a little bit different. It's towards precision monitoring of carbon stocks in tropical forests. Okay, I'm from Faculty of Tropical Forestry, UNC Malaysia Sabah, and on that slide, maybe you will see, maybe you can spot a familiar face. Is also joining the summer school. Is my master student, Lee Ting, and this was taken in one of our field trips. Okay, so before we begin, yeah, so you can just stop me anytime you like, yeah, anytime you like. If you think it is a little bit, for example, you can't hear me, or yeah, someone or it can text me if there's any technical problem. All right, when I'm on a full screen here, so I wouldn't be able to see the chat in Zoom. All right, so this is where I am now, right now. Our faculty is somewhere here, hiding, is not in this picture. This is our campus, and we have a beach. And we have a beach right somewhere here, behind here. All right, so it's a beautiful campus. Allow me to have a few minutes. This is our faculty website. You can see if you want to know more about our faculty. We have 5 programs to offer. I'm actually in the Nature Parks and Recreation program. Yeah. So that's me. Okay. If you like to know about each of the staff, you can click in there and have a look. What is it? The education background. What is our research project, our publication, our research grant, and so on. Yeah. So, all right. So now let's get back to our. Okay, do you see this? The first slide, GS, and global warming. You see this slide, yeah? Okay. So I think everybody knows about this, yeah? And nobody question this anymore compared to like 20, 30 years ago, and people were still doubt about global warming, climate change. So it's become really real, and everybody can feel it. Recently, we also know that the intense hot weather with a strong wind, they cause a catastrophic event in Hawaii, and it caused a lot of death. And it is actually mentioned as some of the among the impact that's caused by climate change. So, so we, of course, we know that actually forestry is not the biggest factor that contribute to global warming or the carbon emissions, but we are one of the significant sector that contribute negatively into this situation. So in I want to share with you, in 2010, I participated in a NASA project, NASA funded project. We actually conducted a global survey in order to find out what is the top priority in Earth observation. So among all the priorities, including oceans and so on, we found that the most important priority is actually vegetation cover and changes, that we need to make sure if this is constantly monitor and observe using Earth observation technologies. So by the meaning of vegetation cover and changes, so it includes deforestation, forest degradation, and also the growth. So there was an online report. So what does it mean? It's actually really concerned us is the deforestation. So that means the permanent land use changes from forest to agricultural use. So for example, this is very familiar to you, a piece of very nice multi-layer tropical rainforest It's burned down because we need to plant something. Yeah. The problem is when we burn down, it releases CO2 into the atmosphere, and also is of course is remove all the carbon that is has been there and is replaced by palm oil or oil palm plantation associated with the removal of wildlife habitats. So this becomes something being criticized by international community, and because of that, yeah, in 2004 they were starting talking about sustainable palm oil, and I think maybe most of you have heard about Roundtable on Sustainable Palm Oil. Okay, so it's an initiative started around 2004 and is actually being enforced and practiced now in the oil palm industry. Yeah. So why am I saying this? Actually, this also related to this topic, which is we should monitor carbon stock with remote sensing, because there are a lot of things in the RSPO needs remote sensing technologies in order to be able, yeah, to confirm about the sustainability of oil palm or palm oil production. Yeah, for example, no deforestation, reduction of GHG, and also no planting on peatland, no fire. All this can be monitored using remote sensing technology. Yeah. For example, I just take one. Yeah, I just take one. Including in this criteria, there's a need to assess what we call high carbon stock forest. Yeah, and there are classifications of what does it mean, high density, carbon density forest. So this is, well, we're able to do it using satellite imagery to classify land cover. In fact, we have a PhD student ongoing working on RSPO, yeah, for example, RSPO using remote sensing technologies. Now, I want to talk more specifically about red cloud. Actually, that is something that directly concerns forestry. RSPO is a mix between agriculture and forestry. So what we want to focus today is red class. Okay, I think Indonesia is also very interested in red class. So the idea of red class is very simple. You have emission, increasing emission. You want to do something about it. So you propose red class activities implemented at this point of time. And after this point of time, okay, the projected increase in that emission now become reduced. So this is the part of the reduction, yeah, we call reduced emission, that actually you will get the credit. So this is called carbon credit. All right. So do you, everybody knows, I believe everybody knows what is red class. Can anyone tell me what the full name of red class? From the student? Anyone can tell me first, what is a RED? R-E-D-D. Anyone? Oh, okay. I see a hand.
Introduce yourself first and where you come from.
Yeah, please.
My name is Nanda.
Okay.
From Cameroon.
Okay.
So the meaning of RED is reduction of emissions, deforestation, and forest degradation. Then the plus stand for including sustainable forest management, forest conservation, and enhancement of forest carbon stock.
Yes, you got it. You got it. Thank you very much. Actually, the original name of RED, actually this started in 2005. It's the idea that proposed by Papua New Guinea and Costa Rica. They proposed to have this because there's a lot of international politics on rainforest. Yeah, talking about You guys in the tropical countries are cutting down forests, removing and also converting it to oil palm and causing carbon dioxide increment in the atmosphere. So because of that, these two countries propose this in order to, okay, let's be fair. We also need money to develop our country. So let's do something about it. So the original name is actually very long, reducing emissions from deforestation and forest degradation in developing countries, specifically in developing countries, all right? The plus is actually later on in Bali, that occurred in 2007 in Indonesia, is one of the very important event, the milestone in Red Plus. Actually, it is the PAS actually formed in Bali COP 13 negotiation. Yeah, if you remember, Bill Clinton get a Peace Award actually based on his involvement in pushing for this Red Plus. Actually, yeah, one of the things that he claimed, yeah, to his achievement in peace of the world. Yeah, so in Malaysia, Malaysia is a voluntary participatory countries in a Red Plus. That means we are not forced to participate, but we volunteered. So when did Malaysia start to participate? That is not entirely clear, but we started to accept about the concept of Red Plus because it's actually Malaysia is one of the countries going to UNFCCC, yeah. So negotiate about what we should do in forestry regarding climate change, all right? So that when this mechanism developed, so Malaysia also very interested. Yeah, when money is concerned, everybody is interested, isn't it? So one of the very important events related to remote sensing is in 2 years later. Oh, there was very specific, yeah, that decided, yeah, in the negotiation there must be a forest reference level. Forest reference level, and they also need to have a mechanism or a system called MRV. It is stands for measurement, reporting, and verification. And Malaysia submitted the National Red Plus Readiness Roadmap to UNFCCC in that year. And then we launched National Red Plus Strategy the year later. And after that, in 2011, actually it's also very important milestone in Red Plus because finally people talking about money. Okay, people say we can't just talk, we need money in order to implement this. So they agree in the UNFCCC negotiation to set up what we call Green Climate Fund. But this funding is based on result. That means you need to show the result, yeah, in order to get the fund. Or you get the fund and you show the result. And in fact, Malaysia also received funding as a UNDP project in 2011, yeah, for Red Plus Readiness. And we actually, as a country, we officially submitted the National Forest Reference Level to UNFCCC in 2016. Okay, in 2017, so we finally presented this to UNFCCC, and finally we are eligible for payment under Red Plus. So that is the status of Red Plus in Malaysia. And in fact, in Sabah, the state where I am now, we are actually called subnational level and national level in Red Plus. Yeah, at the subnational level, actually, Sabah also can ask for, yeah, Red Plus under at the subnational scale, but currently it's under national level. So anyway, Sabah has got also readiness funding in order to implement Red Plus in 2013. In 2013, and that go on for until 2019, where I also involved in several activities under that EU-funded project. Yeah. So this is an example for the Malaysia Forest Reference Level. So what does it mean for reference level? That means it actually create the baseline of your country. What is the removal, carbon, CO2 removal, rate, and also emission. And therefore, you have the net as well. So as you can see, the removal is quite consistent until around millennium. After that, we drop a little bit. And then we actually, now recently, we are increasing a little bit, yeah? The CO2 removal in the forest sector, especially, yeah? We're talking about because our forest area are quite constant now. We are not much deforestation going on in Malaysia, actually, yeah. But the emission level is coming down also. So it's something positive, and so we are looking into at national level, Malaysia government thinks so we will be benefited from participating in that plan. So some country would consider maybe it's not actually that profitable or beneficial to the country. Yeah? So when we consider this, so we must now be able to estimate and monitor your forest carbon stock. And how to do that? Okay, everybody, you are forester, you know, you go to a field, you take your diameter or DBH cap, you measure the DBH cap, voila, you get to know the size of the tree, correct? And then when you measure every of these standing trees, then you actually can use it to convert, yeah, to estimate, yeah, the carbon stock of those trees. Right? But how many trees can you measure? That's the problem, right? Yeah. For example, in Sabah alone, there's about 3.75 million hectares of forest. So how many trees can you measure? So practically, the remote sensing is the only way to make it actually possible in order to implement red class, as well as other things in RSPO, for example. Yeah. So what is remote sensing? I assume, may I see some hands? I just want to see some hands. Any of you who has not taken a course in remote sensing? Anyone? Can you raise your hand? And no, you haven't taken a course. If you have taken a course in remote sensing, you don't have to raise your hand. How many? Oh, all of you know about remote sensing. Great. Okay, so everybody knows about remote sensing. So we are going to be passing through. Yeah. So basically, you have remote sensing is the interaction of, in this case, of the electromagnetic energy from the sun. We are actually not limited to the sun, but basically, mostly we are talking about the sun, where the light travel at a light speed and it actually interact with the atmosphere and get reflected by the surface, for example, by this tree, by this tree, and the reflectance, the energy reflected is now sensed by a sensor on board a platform. In this case, the platform is a satellite, and this data is transmitted to the ground station, and now you or me or some analysts will use this data to analyze to actually be able to use it for estimating carbon stock. All right. So now, what are the platforms we're talking about? Remote sensing can be handheld. You can have a sensor, you use your hand and hold it and measure something. That's also remote sensing. Kite, we can put on a kite, balloon, aeroplane, and of course, satellite. And how about this? Can you guess what it is? It's actually an image taken by a pigeon. Yeah. So during and this is taken by a kite. yeah, above a ship, yeah. So the thing is, we want to get a bird eye view of the landscape, and it's actually a byproduct of war, yeah, of war. If this has been a military byproduct, then we use it for environment purpose, yeah. So of course, today we no longer use pigeon. The poor pigeon has to carry such a heavy camera, yeah. It's about 70 grams during that time, but I think it must be very heavy for the pigeon, I believe. All right. So why remote sensing? Because it covers a big area. Because it repeat every 1 week, every 4 days, every 2 weeks, for example. Landsat is every 16 days, for example. Yeah. And what is good is the data quality is very consistent. Yeah. Consistent data quality is very important. It's not like, oh, today the data is not good, tomorrow is good. So this is not good, right? And what is important is allow us to acquire information in inaccessible area. But there are people used to criticize, oh, you do remote sensing, right? You don't need to go to the field work. Oh, you ask my student there. She will tell you, yes, we have to go to field work. We have to go to field work. This is a picture that we are trying to measure a Pitol cup tree in Daramakot, which is the first, yeah, so the first sustainably managed forest certified, yeah, under Forest Stewardship Council, yeah. And we try to measure this tree, and it's we have to measure up here, and we can't do it, so we have to use some stick and then try to measure the DBH, yeah. And then we also set up, for example, a differential GPS system, yeah, receiver, in order to get very accurate coordinates of the plot location. Yeah, this is the case where I was there to study the fire impact in a peat-swamp forest. Yeah, so we need to go to the field and collect data. Yeah, and I would like to maybe recap a little bit. Yeah, remote sensing. There are a few concepts of resolution, but most importantly is the spatial resolution. For example, Landsat is at 30 meters. ICONOS is the first high-resolution satellite sensor launched in 2000. Yeah, so this is 4 meters, and you can actually nowadays we actually have satellite sensors that produce 50 centimeter resolution or 0.5 meters. Yeah. Okay. The second important resolution is spectral resolution. Usually, this sensor will capture data in certain wavelengths. Invisible wavelength, for example, the blue light has one image, green light has one image, red light has one image, and near infrared, middle infrared, and so on. Yeah. So there are several bands, 200 of them that we call hyperspectral. Okay. So these are the two things important in when we are choosing what remote sensing data to use. All right. So when we look at remote sensing, there are really a lot. You know, there are something that have a resolution of 1 kilometer in only one little square pixel is the size of 1 square kilometer. So it's actually not much use for us, right? But it's actually quite useful when we look at the forest for the whole world, yeah, because the world is so huge, right? But in our operational forest management, we are talking about something like a 50 meter and below. That is what I have been working on. Yeah, in the field of forestry, so I'm using a spatial resolution of 50 meter and below until like 0.5 meters Yeah, something like that. Okay, so another concept we like to briefly mention is in remote sensing, there are two types, what we call a passive remote sensing, which depends on the light of the sun. Yeah, so we need the sun, meaning to say we can only capture an image during a daytime. But when we have active remote sensing, so we don't need the sun because the energy source is from our sensor. Just like we have a pointer, laser pointer, example, LiDAR, laser scanning. Yeah, the same concept as laser pointer. You emit an energy, you click on the button, a small red light, that is the energy in the infrared. Yeah, in infrared wavelength, it will beam on the surface of an object and it will get reflected. Yeah, so we measure that energy. So that is active remote sensing. Okay, so this is example will be like Iconos is a passive. It depends on the sun energy. This one doesn't depend on sun energy. Okay. Now, when you have the remote sensing data, what do? You pre-process it. You interpret it. You try to extract information. So, for example, you transform them or you classify them. So I'm just going to be very quick about this. We are skipping all this, yeah, only a little bit, yeah, about transformation and classification, because they have got to do with our carbon stock estimation, right? And at this stage, at several stages, we need ground truthing. That means your field data. We need that. Not that we don't need, yeah, we need that. Yeah. All right. So one of the transformation techniques we can use is to transform the reflected energy captured by the sensor as vegetation index. If you take a course, if you have taken a course in remote sensing, this is very familiar to you. All right. This is the typical, the green curve is a typical, yeah, reflectance pattern of a green vegetation. Yeah, only green vegetation, right? So our eyes can see on this visible wavelength. I don't know if you can see in the near infrared. Anyone? If you can see in near infrared, you are superhuman. you are Superman. All right. So, but our eyes only see invisible, yeah, blue, green, and red. So because therefore we see the vegetation in green because they reflected mostly green color, green light, yeah. And there in the blue and red is actually the chlorophyll absorption. That is the cause they absorb most of the energy in these two wavelength regions so that they actually make food for themselves. Okay, so the food will be stored and they form the carbon. That's where our carbon stock are, right? So what is important is we got to know these are the region that is always record the lowest value in the satellite imagery. All right, and the highest will come from here in the near infrared region because the cell structure, yeah, the cell structure, the leaf, the branches actually reflect a lot. They don't absorb. They reflect a lot in the near infrared wavelength region. Okay, now this is the highest, this is the lowest, and we also see some low region here is because of the water. What water got to do with vegetation? We do know vegetation have moisture content, right? So it is the moisture content in the vegetation, especially in the leaf. Yeah, they store water, and the more water it has, the more absorption. Yeah, the reflected energy is lower and lower. So when it is dry, this will go up and up. Okay? So based on this, various index we can form. For example, taking the difference, the maximum minus the lowest, maximum minus the minimum. It can be index, or this one minus this one. Or we can take a ratio, for example. So there are a lot of vegetation index, more than 50, I believe. Yeah, and these are among the most common, and this is actually among the oldest vegetation index. Is called normalized difference vegetation index. I think some of you are very familiar with it, or maybe you heard about it. Okay, so it's very simple. It takes the maximum just now, the near infrared minus the red, so you get the difference, the largest difference. Then you normalize by the sum of these two. Okay, so that the value now range between -1 to +1, -2 +1. So anything, if it is not vegetation, it stays somewhere 0, 0. Anything with water, it will go to negative. And anything with vegetation, it will start become positive towards 1. Of course, highest theoretically is 1, right? So most of the index you will see is using near infrared and red, near infrared and red. And this one use near infrared and the short wave infrared to capture the moisture. This is called normalized difference water index. Okay, I also use this to study fire. All right, so this is an example. This is an image in the one of the so-called the tallest mountain in Southeast Asia. I actually think they are taller mountain in Indonesia. All right, it's a Mount Kinabalu is here. So this is the image. Actually, I'm just somewhere down here. Okay, so this is the original image in force color composite. And you can see after we transform. So what's the point of transforming this? Because this is just for display. We just mix up 3 different reflectance bands, yeah, spectral bands, to form a colorful image. But we can't really use it just like this. You can only see, oh, this color is what, or that color is what. You can only interpret it. That means qualitative analysis. But what we want is quantitative analysis. So we transform the example to an NDVI image. So this -1, +1 is something like the red. Yeah, so that would be the highest value, highest vegetation amount, maybe biomass. Yeah. All right. Beside of that, what can we do? Classification, right? Everybody familiar about classification? Yes, we do. Humans like to classify, right? We like to classify. We like to, vegetation, we like to classify to all lowland rainforests, all montane rainforests, or even montane rainforests. We want to classify further to, for example, lower montane and upper montane, right? We like to classify. And we like to make a map that have forest type 1, 2, 3, 4. Okay, so in order to do that, we select training field. All right, like this green color will be vegetation. This is the burn area. Yeah, in red. Yeah. This is training area. Yeah, on the screen we digitize. Oh, this is the one burn in the forest fire. Oh, this is the dam. Yeah, water dam, water area. In violet, for example. And then you got like this blue color is a city, urban area. Yeah. Then we have this we call signature. Yeah, we submit to the computer, and computer will run the classification, classify it, and we need to evaluate whether it's accurate or not. Simple, right? So, for example, the training area just now will give the computer this kind of statistic, okay, based on the training area. What's the mean vector? what's the covariance matrix, and this thing will be used by the computer. We're not doing it. We're not doing it. The computer will run it. All right. That's why sometimes we say garbage in, garbage out. That means it depends on how well you select the training area. If you're very experienced, you can do it very well. You will get a very good map. Otherwise, you will not get a very good map. For example, this is a very good map. Why do I say that? Because it's in a textbook. Right? And this is from a textbook. All right. So you can have that. And why is this important? Because this methodology is used. This is a standard methodology, is used and recognized by that class. Okay? All right? Until here, okay, everybody? Okay? If you okay, show me your hand with the thumbs up. Okay, thank you. All right, great, good students. Okay. Now, how do we use the remote sensing to estimate biomass? When we talk about biomass, of course, there are a lot of carbon pool, right? There are carbon in the above ground biomass. There are carbon on the little layer. There are carbon in the soil, carbon on the below ground. But if you search in literature, there is always about estimation of above ground biomass. Why not below ground? Yeah, why not little? Why people keep talking about estimation of above ground biomass? Can anybody tell me that? From the student, why? It's a bit too difficult. Anybody? Or we can reserve this and discuss about this later during the Q&A session, yeah? Yeah? Okay? Okay? All right. So we continue a little bit, yeah? We continue a little bit. So just now I mentioned, yeah, in UNFCCC COP negotiation 2009, there's what we call Copenhagen Accord, yeah? One of the important, yeah, decision making is, yeah, how to actually estimate and monitor carbon stock. So it actually recommend use of a combination of remote sensing and ground-based forest carbon inventory approaches for estimating as appropriate the total emissions by sources and removals by sink, forest carbon stock, and forest area changes. So this actually means we actually be able to estimate the carbon emission based on the area of forest type between 2 times period. Example, between 2015 and 2020, for example. And that change of area is deforestation, right? Okay. So if we have the area, we only need the emission factor. So how much carbon per hectare, for example? Then times the hectare, then we can know how much carbon stock actually lost between 2015 and 2020, yeah? Right? So this, we can get it from land cover classification. And this we can get from field inventory, right? That's why we say we cannot avoid field inventory just because we are doing remote sensing. That is not true at all. All right. So given the situation and this approach, meaning to say, when we want to, let's say Indonesia want to initiate RED+, okay, we want to officially, they're saying that we will start RED+ 2023 this year, okay? So before that, you already need to have the forest reference level. That means from 5 years before and another 5 years before, what was your emission and removal level, right? Then next, you will monitor in order to show actually by doing that, yeah, the forest area, yeah, is it, you have to keep it not reducing, yeah, but increasing so that your removal is reducing, yeah. Okay, so this is something very difficult. You need to keep your forest area not only not reducing, but it's increasing, right? Correct? Only then the CO2 removal will be reducing, right? The emission will be reducing, sorry. Yeah. So like this, yeah, you have all the land cover classification, for example, using spot data, landscape data, and so on. Yeah, so many satellite images. Yeah, then you can check this area, yeah, increase or decrease throughout the years. Yeah, of course, this classification need to have training data, need to have ground truth data, need to have validation data. Okay. So, for example, in Malaysia forest reference level, okay, we use satellite image classification. And then we have 3 forest classes: inland forest, peat swamp forest, mangrove forest. Yeah, put a question mark here. What is the issue? What's the issue? I think there is an issue. So, but what is the issue? So this is a thing that we should discuss. Okay, it actually affects the accuracy. Yeah, this approach affecting accuracy. All right. So we are currently mostly in this level, tier 2. Yeah, because we use both remote sensing and field inventory. Right. Only countries with very least capability, they cannot do their own remote sensing analysis. All right. So they will use, let's say somebody do a whole world mapping, okay, of forest area, then tell you what is the forest cover in 2020 for Malaysia, for example. Then we just use that number. We cannot do it by ourselves. All right. But we can do it in the field. For example, we can go to measure some trees. So we can generate the carbon emission factor. Okay, carbon factor. Yeah? All right. So, but we want to do a higher order method, and it can repeat over time and support full carbon accounting model. Yeah. Of course, the difficulty level will become much higher. Yeah. Okay. Therefore, I'm going to share with you some of the things we have done. For example, land cover classification, what we can improve. We can improve by changing from pixel-based to object-based land cover classification. Okay, let's see some example. What does it mean? First, what does it mean object-based classification? What does it mean pixel-based? Everybody knows about pixel. When you take you see a, let's say I see a, let's say a very cute rabbit, I take out my camera and I take a picture, right? And I zoom in until I can see a little square. So that is a pixel. Yeah, pixel stands for pictorial element. So if you classify that image, it's based on pixel. That means you classify one by one this pixel. What's the problem? Later on, I'll tell you what's the problem. But the new approach is not classifying pixel by pixel. We group the pixel to become object in a process called segmentation, and we classify. The rest is the same as the explanation just now. Then we classify not the pixel, but the whole object. So what does it mean, object? Okay, this I download from internet many years ago for a conference presentation. And I think this is in Japanese. Shinrin means forest, and this is the green color. Nochi means agriculture field. Hoshi means urban area, and Kase means river. Yeah, river. So you can see if this is pixel by pixel, for example, this object. Can you see they are whitish color and they are a little bit more pink? So you see there will be very different variations. Yeah. So you will see a lot of dot in your classification result. There can be a mix-up between different forest types. So that actually will reduce the accuracy. But by grouping it, so we can classify the whole thing as forest, for example. This whole thing is urban area. Let's see an example. Okay. This is from a paper that I published recently on fire impact in peatstorm forest, and we study about the how this actually affects the recovery of peatstorm forest by using high resolution satellite imagery. All right. So you see, if we use the pixel-based classification, we can achieve around, let's say, this is already very good, 88%. But if we use object-based, we need to make sure the object-based is appropriate, has an appropriate scale, the resolution. Yeah, otherwise it's actually not better. It's worse than the pixel-based. But if you do a correct object-based classification, you actually can achieve more than 90%. Yeah. So how does it look like? This is pixel-based. Okay, using maximum likelihood algorithm. So what's wrong with this? This is a burn peatstorm forest. The burn area. This is the burn area. Yeah, we make the study here. Look at the circle area. Can you see? This is pixel-based. This is object-based. You can see the mix of other color become much lesser in object-based, become more homogeneous. For example, these are grass or basically grass and shrub. Yeah, but these are continuous forest canopy. You see, but in pixel-based, actually many of these pixels are classified as grass or shrub. But this is the part that not affected by fire. Yeah, the place affected by fire basically are covered by grassland or shrubland. Yeah, a lot of fern, for example. Yeah, so you can see actually is become much better. At least this we can do. But another approach, not by classification, but trying to use regression. Everybody familiar with regression, right? You want to correlate certain things to predict another thing. In this case, to predict the biomass. And usually, vegetation index. That's why I explain a little bit about vegetation index. Right? We want to use vegetation index to estimate biomass. Why? Because vegetation index means the lower value, no vegetation. Higher value and higher, more and more biomass. Suppose. Yeah. But this concept is correct. It's correct. Nothing wrong with it. Yeah. So actually, when I was doing my master, my master project is actually trying to use vegetation index to estimate biomass. But it didn't work. Yeah, it didn't work. It saturates. When the biomass is correct, yeah, don't get me wrong. Don't get it wrong, yeah. It's correct. It correlates positively. The vegetation index increase and the biomass also increase, but only until certain level. After that, it doesn't increase, it becomes flat. When the biomass is about 200 megagram per hectare, it will stay flat. although the biomass increasing, but the vegetation index doesn't increase. So it's saturated. So, but during that master study, then I figure out, okay, in that case, I don't predict biomass, but I predict crown diameter, because there's a good relation between crown diameter and biomass. So I try to do that, but it's still not so good. It's still not so good. But that gives me idea that if I have very high resolution satellite images, maybe I can do that. Why? Because now I can detect the tree crowns like this. This is ICONOS 2 image. Yeah, it's a huge progress in remote sensing when a US Congress approved that civilian satellite now can actually produce an image with 1 meter resolution and below. Before 2000 millennium, yeah, it wasn't allowed. Nobody can do that. Only military has the power to produce that. So now we can actually use it to detect the tree crown. Yeah, intact to more and more degraded crown. Yeah, okay. So we do that, and of course, in the field, we need to, this is my master student that did that project, and I won a Green Asia Award, yeah, for that paper, yeah, presented in Asia Conference on Remote Sensing. Yeah, so we do that, and this is the crown area from the ICONOS image, and we use it to estimate the field dBH. Yeah, we produce a model, but you can see a lot of variations here. Yeah, no variations here. Yeah, in the intact forest and degraded forest, we separate intact and degraded forest, and then we detect the crown. We detect the tree crown area, and then we compare. This is the estimation outcome. You can see actually this is very good estimation, except in the larger crown. Yeah, you see a lot of variations here. Yeah, in a larger crown, larger dBH. Yeah. So, but this approach allow us to what? Allow us to estimate. This is the biomass of each tree, individual tree. You see, this is intact forest. They are more high biomass. The darker green is high biomass, and compared to the degraded forest. So it allows us to do that. But, yeah, this has about 30% error. Yeah, the RMSE, root mean square error, is about 34%, yeah, of the average AGB. Okay. Why? Because the crown only detected for the upper canopy tree. Because the satellite can only see the tree up there. But we know that our rainforest has many layers, right? There are many more trees under the top emergent trees. Okay? So then we actually start to develop method using airborne laser scanning or light detection and ranging with LiDAR. Can I know how many more minutes do I have? How many more minutes do I have? How many more time do I have?
Berapa menit lagi Mbak waktunya?
Berapa menit lagi saya ada?
You can finish your presentation, I think, Professor.
It's about time?
Yeah, still, you still have time.
How much time? I can finish, no problem, yeah? All right. Okay, great. Yeah, I can see, I think I have like 20 minutes more, yeah? Okay. Now, I think most of you heard about LiDAR. Correct? LiDAR is just like the concept of laser pointing device, laser pointer. I told you that we use in the presentation, yeah, that this sensor actually emits LiDAR pulses, energy from near infrared region, usually, yeah, infrared region, and it just beams towards the ground. How much they emit LiDAR pulse, the laser pulses is like, you can set it. You can set like 3,000 pulses per second, or 200,000, sorry, 200 to 300,000 pulses per second. You can set that. Imagine hundreds of thousands of these pulses hit the surface. It's so dense every second. Then the airplane or helicopter or whatever that bring the sensor. Yeah. So the reflection, the reflectance from the surface will be captured as measured as time, yeah. Not the strength of the reflectance is important, but it's the time of the return. That means if the time is shorter, that means it's higher, right? If the time required is longer, that means it's lower, right? So this allows us to know which object is taller and shorter. And the pulses taking longest time to return will be the ground, right? So this is a very important idea. This allows us to have three-dimensional data for our carbon stock estimation. Yeah. So basically, you scan it, you correct it, we pre-process it. For example, some error corrections, and then you will have a point cloud, what we call a point cloud. Yeah. Then using this point cloud, this point cloud, you can generate something called digital terrain model, the ground level, and then the canopy height model. Yeah. Only the forest canopy, for example. Then we use that to analyze, to model, to predict biomass, for example. Right? So in UMS, we have our own LiDAR sensor. This is Optec Orion C200. It costs us a lot of money. Yeah, that costs us about 1 million ringgit, or about $300,000. Yeah, this is this model. Yeah, we have it to fly over to many research sites. Yeah, this the red colors is the site that we have been doing study. Yeah, for example, this one is we scanned twice. One in 2012, one in 2017. Yeah, yeah. This is the montane rainforest. Sipilok is a lowland rainforest. Denham Valley is a cuticle forest, and this is a plantation here. And number 2 is an IKEA sponsor funded restoration project. And we also have studied mangrove biomass estimation using LiDAR here, somewhere here. Yeah. In fact, I just submitted a paper into a journal 2 days ago on this project. Yeah. So, for example, yeah, this in primary lowland rainforest. So in Sipilo, yeah, we study carbon stock estimation in restoration project. This one we are still writing our manuscript, and also we compare, yeah, in log over against primary forest, in mangrove forest, yeah, and also in plantation forest. And this is the one that in montane rainforest. So we use airborne LiDAR in various forest types in order to know the capability of so-called the most accurate remote sensing technology in carbon stock estimation. To that, I dare to say there is no other remote sensing technology is more accurate than airborne LiDAR, or laser scanning. None. Okay? And example, yeah. So this is our study area in Sipilo, yeah. So we, for example, first we, of course, in the lab, we make the flight plan, and we give to the pilot, we supply to the monitor. We have this monitor, yeah, installed on the airplane, yeah. We install the sensor, this is our sensor, yeah. We install it, it looks like this, Orion C200, and we fly it, and this is during the flight. So we capture the data. We can monitor the data capture, and we scan. When we scan this, we also at the same time on the ground, we need to have a base station to record highly accurate positioning, yeah, in order to use it to correct this LiDAR data. Yeah. For example, in this project, we scanned about 2,200 hectares. That took about 45 minutes. Yeah, all right. So this is some example of pre-processing. This is the individual LiDAR raw data. You can see like this. So we need to make sure they are matched. For example, between this flight line and that flight line. Why? Because the airplane flying this flight line according to our flight plan. In the next flight line, it could be a slightly up or like this tilt a little bit, you know. So the positioning needs to be corrected. So we need to make sure they are overlap using the overlap part. Yeah, you can see the blue point and the green point need to be correct until they're actually matching. All right. For example, this is example of the yellow and red. Sorry, the box should be here. I think when I edit the slide, it's gone a bit. So they are perfectly matched. Yeah. Then we can have the correct point cloud. Yeah. And you can see the 3D structure of the rainforest. See the emergent trees here and here. Maybe this is a composite excelsa. And the ground level. See? The ground level. And in Sipiluk, we have 3 different types of forests. Here we have alluvial, we have heath, we have sandstone hill forest. Yeah? 3 different types. Yeah? If you come to Sabah, you'll enjoy it. There are also orangutan in this forest. It's a famous orangutan rehabilitation center. So, but what can we do with those point clouds? Okay, we can, for example, to compute height variables like maximum height or certain percentile height at 90%, 90th percentile height. For example, the mean height. And beside that, we also can compute laser penetration rate. For example, the proportion of the last return under certain meter height. For example, what is the proportion of the last return? For example, 7 meter and below, 10 meter and below, 12 meter and below, for example. So that allow us to know how dense is the canopy. So the densest part would be probably the most correlating with biomass, for example. Yeah. So this, then, of course, we do statistical modeling. Yeah, we do. Usually we do multiple linear regression. So how good is it? How good? I keep saying it's the most accurate. So how good? That's how we know using the high resolution satellite imagery, we still got about 30%. Yeah, 30% RMSE. So how good is LiDAR? For example, in our study case is Danone Valley. Yeah, now this is the canopy surface model, digital surface model. Sorry, yeah. Digital terrain model, if we minus this, we get the canopy height. Okay, so we overlay with the plot data. Okay, we can sample it, we can compute the height variables, and we can also make a raster of it. in this case, only one single variable, yeah, that predicts the above ground biomass. Okay, mean height. And the relative RMS is about 22%. Now it's down 10% lower.
Sorry, Prof. You
Yeah.
still have 5 minutes more.
Sure, that's enough. Yeah. Okay.
5 minutes.
Yeah. Sure. It doesn't look like 5 minutes.
Still have 5 minutes to
Sure.
5 minutes.
Sure. Okay. So now we also think, how can we improve? Can we improve? Yes, we can. We improve by not only LiDAR, but we combine LiDAR and Landsat. LiDAR and Landsat. If we use LiDAR alone, we have 27% RMSE in Sipilo. It's another different side. If I use Landsat alone, it's almost 30%. If I combine them, now it becomes 20%. Okay? This study area is very difficult. Yeah. So this is a LiDAR plus Landsat result. Okay. The final case study I want to show you, in the mountain rainforest, we study not only carbon stock estimation, but the changes. The most difficult part is to study the changes. So we have one LiDAR in 2012 and one LiDAR in 2017. We just published it. Yeah. So we have model for each year. So we have the above ground biomass map for 2012 and 2017. The same study site. You notice there are differences, right? There are changes. You notice there are more red in 2012. Okay? Now here it becomes not so red, but we have something new, reddish area here. What are those? These are the reduced impact logging areas. Okay, now let's see. If we minus this, the biomass in 2017 and 2012, we get the changes. And then we divide it by year. Okay, so how good is this? This is based on the field data. This is based on the LiDAR estimate AGB changes. You see, it's almost y equal x. This is a y equal x line. It's all the plot aligned nicely near this equal line. Okay? You can see y equal 1.11x. What does it mean? It means y is about 1.11 times of x. That means it's only overestimate overall about 11%. Actually, yeah. So what can we learn from here? We actually can know about, okay, this is sustainable forest management system compartment. They have a mean of 9 megagram per hectare per year increment rate and have a reduction rate of 7.38 megagram per hectare per year. But we can know if during these 5 years, actually is the kampong area, the village area, the state land that has a higher carbon amount losing due to this area, due to the conversion of the forest to rubber plantation, actually. Then we actually can use LiDAR to pinpoint the exact driver of the carbon stock changes. Yeah, all right. So the last slide. All right. So I think we need to move forward by mainstreaming environmental services of forest. We are not talking about only carbon sequestration. Yeah, we are also talking about other things, water resources and so on in national development. Yeah, in Malaysia or in Indonesia or in any other country. And we need for REDD+ and other carbon stock estimation. What we really need is a cost-effective remote sensing approach in MRV and FRM. LiDAR is very accurate but expensive. So we should explore combined use of LiDAR or airborne laser scanning with unmanned aerial vehicles like UAV, drone. Actually, we also work on drone actually, but we not yet using LiDAR plus drone. This is only drone. Only drone, we build our own drone and we fly them. This is the example of canopy height model, like the one that produced by LiDAR, but the accuracy is a little bit lower. So I think now LiDAR sensor is getting smaller. Our sensor is about this size, this size, about 60, 70 kilograms. It's very hard. You need to install on an aeroplane, and it's expensive to fly an aeroplane. But now LiDAR sensor becoming really small, like this size. This size. We can install on a drone. And now this becomes very operational and very accurate for project-based carbon stock assessment. I think in Indonesia also there are many project-based carbon stock estimation. All right. I think this is maybe is one of the way to go for smaller project-based activity. All right. But for national activity, it has to be something more cheaper and more cost effective. All right. I think that's all. Thank you very much. Terima kasih.
Terima kasih. Luar biasa. Great appreciation to Professor Phua for sharing a brilliant presentation with us. Very sequential, really technical. And ladies and gentlemen, I believe that many of you have been saving a lot of questions. So without further ado, we are going to move on the Q&A session. For the first opportunity, we will open the questions. So please raise your hand, guys, for questions.
Yeah, don't be shy. If I cannot answer you, I'll get back to you some other time.
Please introduce yourself and from.
Yes, thank you. My name is Kia from Thailand, and the question that I want to ask is this: about according to the carbon emission formula that you have just said, that the combination between two informations from the remote sensing part and the inventory parts. So I would like to ask that, what if the situation that it is the restricted areas and unreachable areas, how will we calculate the carbon emission, and will the accumulated information is reliable and the percentages of reliable? Thank you.
You said, are you from Thailand? Where are you from?
I'm from Thailand.
Okay. Thank you. Good question. So this is a basic formula. Okay. How do we implement it? Okay. Depends on each country. And each country has to make the best effort they could to make sure the estimation is unbiased and accurate. But in Red Plus, we understand that different countries have different capabilities. So this is most important. Actually, in Red Plus, it's not compulsory, and it's not. That's why they never say you must use this method. No, it actually always depends on each country what capability that you have. For example, Thailand is very advanced in remote sensing as well. Yeah, in this region, right? So if you can, you need to make sure. For example, most of the time, countries actually establishing these emission factors by using permanent plots. You have heard about it. Even in Thailand also, you have permanent plot set up. In Indonesia also, in Malaysia also. They usually use this, okay? But it's also accepting project-based. For example, some research project, you make measurement of standing trees carbon, above ground carbon, for example. They can also be used, especially when your sampling is unbiased. And how to prove that is when you can publish your research, right? So if you can publish your research, basically your sampling is good, right? So, but when you talk about inaccessible area, right? So now it's the question of how representative is your field sampling plot, right? If the inaccessible area still have the same forest type with the location of your sampling plot, there is no issue at all, isn't it? So now that link to the question of, in fact, your question linked to this question. Do you still can see my presentation? You still can see this slide? Yes? If
Okay,
yes,
thumbs up.
please raise your hand. Okay, you can see. So this actually come to here. What is the issue? The issue of this approach is this approach is because it's only used area. For example, in Thailand, for example, what forest type do you have? We have, for example, a seasonal forest. We have also at the same time, you also have evergreen forest. I don't know, maybe something like that. Yeah, but this is only area. What does it mean? It's only classified and generate an image like yeah, like this. It means, for example, this color is forest. And all this color, when it is the same color, you get the area, let's say 100,000 hectare times a carbon emission factor. It means, it assumes all these forests have the same carbon emission value, same carbon stock. So that is the problem. Because we know that they are not the same. All right? There are areas which have higher carbon stock and lower carbon stock, even in the same type of forest. So that's why this cannot be considered as tier 3. Okay? I hope I answer your question.
Okay. Thank you, Professor, for your answer. And then next question, please. Yeah. Introduce yourself, Drew.
Thank you, Professor, for the presentation on this interesting topic. My name is Nanda. I'm from Cameroon.
Okay.
My question is about Red Plus. I would like to know what is the state of implementation of Red Plus in Malaysia, because in our perspective in Cameroon in particular, but globally in Africa, the situation is a little bit complicated. Since 2007 that the process was launched, we have been working toward elaborating the Red Plus component in several forests in my country. Me particularly, I've been involved in several Red Plus projects. A lot of people, they invested their money to like make studies related to carbon stock measurement. Personally, I did a lot of field forest inventories for carbon stock measurement and evaluation. And the country has already submitted the national strategic plan and also several Congo Basin countries. But the payment is still, we are still waiting for the payment. So at the end of the day, people are not even believing in this stuff because they believe it's like just like a scam. We developed the document based on the different standard. I remember I work on a CVS carbon verification standard, which is now VERA. Yeah, and we saw all the document, but the payment is still awaiting. So I want to know if here in Southeast Asia, you already receive any kind of payment related to Red Plus.
Okay, that is a question you should not ask me. You should ask the treasurer of my government. Okay, let's make it clear. Let's make it clear. Let's make it clear. Okay. Web Plus is a very complicated process. And every year is negotiated under UNFCCC in Conference of Parties. Every year in different place, okay? And every developing country is now demanding for payment, okay? And to be frank, since the so-called Green Climate Fund has been, if you can see my slide here, in 2011, yeah, was agreed, this decision was agreed. Then starting from there, a lot of developed countries making what we call the green funding, what's the right word? Plea, or they say, okay, we would contribute how much money, okay? But all this go to United Nations, and this money are dispersed based on applications from so many countries, from Africa, from Southeast Asia, from this South America, and so on, right? And this money are usually dispersed as a readiness project. I think maybe Cameroon also have received Red Plus readiness funding, usually through UNDP, for example. Okay, this is the process under United Nations, UNFCCC. But from your description just now, there's a mix of different things in your description. Okay, carbon stock assessment for the money to be paid for this carbon capture is not only from Red Plus. There are also other market-driven voluntary carbon credit mechanisms, like those is being sold at the global level in certain carbon market itself. It says a carbon price. If you want, you can sell it as a project, for example. Or there are also, that's why I think the situation is very complicated. That's why you have Vera certification standard and so something like that. It's a independent certification standard. If you would like to take that, it means actually just like an ISO standard to say, oh, our product has a quality assurance, for example. That means I can assure you, if I say there are how many tons per hectare of carbon in this project area, total will be how many million tons of carbon. And who wants to buy it? Now it's being certified compared to not certified. So of course, people tend to want to buy the certified product, right? So, but this is not Red Plus. Okay? Don't get it wrong. Don't mix two things up. Then at the same time, also other things. For example, you asked about what's the development in Malaysia. In Red Plus, actually, the latest development will be in 2017, we became eligible for result-based payment in Red Plus. That means the country make the effort and need to submit the claim to UNFCCC. And in fact, certain claim is still under this green climate fund as readiness as transformative fund. For example, Malaysia recently also received a climate fund to transform the city. For example, transform the transportation, one of the biggest CO2 emission sector, yeah, transportation, for example. But maybe people are not very clear about how this money being paid. Usually, there are certain funding scheme that will be advertised in the UNFCCC related, yeah. And some of these countries You see, there is a lot of international politics here. They don't want to go under UNFCCC. So maybe EU has its own funding mechanism. They want to sign a bilateral ties with another country, for example, with Indonesia. Okay, Indonesia, you sell me, you create this kind of carbon credit and still sell to EU because we need it. Understand? So situations are very diverse and complex. Okay, it's not a question that I can answer you satisfactorily. It's not really my expertise here, yeah, but I can explain to you that much. Okay, thank you.
Okay, thank you, Professor, for very, very clear perspective. And I think the time is up. So I would like to express my gratitude to all participants who have expressed their interest regarding this topic. And then as we have reached the end of our session, I would like to say thank you so much, Professor Dr. Mui How Phua, for your incredible lecture in this morning. On behalf of the Forestry GM Summer Course, Managing Forestry Landscape and Forest Dependent Communities to Bridge the Future, Learning Across Governance Regimes, thank you all for making time to join us here today. Now, I would like to return the time and place to the Master of Ceremony. Thank you for your attention. Thank you, Professor Phua.
You're
Assalamualaikum
welcome.
warahmatullahi wabarakatuh.
You're welcome. Thank you very much.
Thank you, Professor Mura. Thank you also, Mas Abdul, as our moderator today. We are so appreciate you for having us to knowing about the carbon stocks for today. Perhaps the audio couldn't hear clearly, but don't worry, it's because the OC will upload all of the materials, including the yesterday materials in Google Drive, so the participants can access it later. Well, thank you so much, Dr. Mui. Okay, because our second topic already end, so please, all of the participants, let raise and take photos in front of here with Professor.
Oh, we are going to take a picture, yeah?
Let's take a picture, Professor. Who is the photographer? Yeah.
Participants can make a half side in left and in the right side